Hello again, and today we are going to study a very important topic in math without which we can say that math would not exist. And what is that? That is number system. Now if we just observe over here, we have different kind of symbols. Can you just try to identify these symbols? Like we have this symbol over here, then we have this symbol over here, then we have this, and we have this. So what kind of symbol do you think they are actually? We'll try to work out in this. Now the first thing which we want to analyze, that probably this symbol is very close to our current symbol, which is like this, and probably we would want to think that this symbol in math we might identify when we're doing the counting, like let's say 1 and 2 and 3. But have we ever thought that these numbers 1 to 3, did they exist right from the start, let's say 1,000 years back or 2,000 years back? So we'll try to explore that possibility. But first let's take an example that we are going to school, and in school we have our classes, and in our classes we have grades or class, and as we know there is a board over the class, so we say that this is class 1, and then the next class is, let's say, class 2, and the next is class 3. But what happens when we go to next class? So after 3, what comes is this symbol. And I always wonder that why after 3 we do not use 4 bars to get the number 4. Why we don't use 4 bars as we use 3 bars over here, or as we use 2 bars over here. Now this is just because we are using the number system which is Roman number system. And what Romans actually used, a system which was one of the oldest system, and in that system essentially we had a few symbols if we try to identify. So we had symbol which is 1 over here, and then we had symbol 5 over here, and then we have this X representing 10 over here. Now if we try to just play and understand how the Roman system actually worked, we'll just make some space and try to identify that how Roman system actually worked was in a way that first we try to put bars as we have done over here. This 1 bar gives 1, this gives 2, 3 bars give me 3. Now the 5th bar, if I just leave the space of 4, the 5th bar, the 5th number basically 1, 2, 3, 4, 5 is represented by the number, let's say, V. And when I want to go back to 4, how it goes it, the rule says that this is one of my numbers through which I'll take the previous number, and it will be like V and 1 getting subtracted. If it comes before, it will get subtracted. So if this represents 5, then this will be essentially 5 minus 1, which gives me 4. So this symbol 4 comes from this one of the rules, that these are the basic numbers, I being 1 and V being 5. Now what if I want to extend and I want to go beyond 5? So I'll again put V in Roman, and then I'll put this 1 bar extended, that is after V, and it will just give me 5 plus 1, which is 6. So we have various kind of number systems. Now the problem with these kind of number systems we'll just discuss in a couple of minutes, but we also want to identify that there are some other kind of number systems. The other number systems have the symbols, let's say we have these 1, and we have 2, and we have 3, yeah, and these are various kind of number systems. So when we're talking about number systems, we need to understand that in history various civilizations made various symbols through which actually we are trying to make some numbers. Now, we'll come back to these kind of number systems. Yeah, we'll come back to these numbers later. But what we want to come back and understand the Roman number system, that why Roman number system does not continue to exist in today's world. So let's extend our understanding and go back. After V, we get something called 10. So for example, you are in 10th grade. So we will just write over here with some space. So suppose you are in 10th grade, you are studying 10th class. So I'll write, okay, you are in 10th standard. Yeah. And what happens, suppose you want to extend it to the number 50. So for 50, we are using the word L. For C, we are using the word. For 100, we are using the word C. For 50, we are using the letter L. So here are some basic numbers we'll just try to place. So we have this example over here, for example, 69 in today's representation. So if I want to represent 69, so what I want to do probably is I want to split it into 60 and 9. Now as per Roman system, what they did was they split 60 further into 50 and 10. So when we split further this into 50 and 10, so 50 we know is represented by the letter L. So I'll put the letter L over here, and 10 is where I get the letter X. So I put it X. Now since we are not used to this number system, you might be thinking that what weird thing is going on over here. I really understand what you're thinking, but this is very important, that why we moved away from this system to the current system, we want to understand. So that's why we are just going back into a little bit of history. Now when we get 50 over here and we are going to add 9, so 9 was what? After 6, if we go back, we get V 1 1 or I we go 7, we go 8. Now over here it stops, and for getting 9 they go to the base value over here 10. So 10 is like this, and if I want to get 9, so what I do over here is I put this value X and I put 1 below. So as we subtracted in case of over here 5 minus 1, so we do 10 minus 1 and we get this symbol as 9. So I put over here 9, this symbol, if you see, 9. And when I put 9 over here, I put it like this, X and this letter over here which subtracts, and ultimately I get this as my representation of 69. Now this kind of system I just want to understand, and probably we may want to understand together, that is it quite easy to work out or it's quite difficult. Let's say you want to add 69 with 89. Yeah, so what kind of a representation would that be? Will it be easy or will it be difficult? Well, let's say you just want to subtract 89 and 69. So what kind of subtraction will that be in case of Roman numerals? It would be very difficult. So that's why we may want to just get rid of it and look for some new ways. So I'll just rub it and try to find out which can be the new ways of representation. So going back into history, we know that there have been various civilizations. There were Indus civilization, there were Greek civilizations, and there were a golden age of Middle East, which we know. And in that golden age of Middle East, we know the numbers came like 1, 2, 3, 4, 5. And similarly, they go up to 10, like they go up to 10, the 10 being like this. Yeah. Now, what does this represent? We want to understand. So, we also have some contribution from a famous mathematician who is called Aryabhat. Now, Aryabhat has a significant contribution in mathematics, through which people say that nowadays majority of our problems solved. So he gave a representation of a number which is very important, which sometimes, as I discussed in last class, it's called Shunya. Now Shunya comes from some of the scriptures, let's say, but what does it mean? It means a number which neutralizes everything and which may also help to increase the value. Now a practical problem which we may have is, suppose I have these 3 eggs over here and these eggs are to be taken off, or they are to be broken off, and finally what value do you get? So that value was represented by the number 0. And also when you keep on increasing, like if this is my 1, if this is my 2, this is my 3, this is 4, and this is 5, and this keeps over here, and further there are representations like this. Yeah, so these numbers ultimately are in the same form: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now all these numbers, when you look carefully, these numbers were added with the number 0, and so a new kind of number system came, which is called Indo or Hindu and Arabic numeral system. So this whole Indo-Hindu or Arabic numeral system came together with the contribution of some Middle East, the contribution of Middle East exploration of numbers, and our 0 and our own counting system. Now how this came into existence, how this helped, would be understood in just a minute. So probably I want to rub this part of the history, and we just want to explore that how this system actually helped us in exploration of numbers. Now let's say that in modern education system, we came to represent these numbers in form of mostly English numbers. So our English number of 1, 2, 3 would be something like this. This can be 1, and this can be 2, and this can be 3, and 4, and 5, and 6, and 7, and 8, and 9. And what should come over here? So we should get the same number over here, 1. Now what I want to explain over here is that it is not 10 actually. It actually represents, if this represents, one ball represent 1, 2 ball represent 2, 3 ball represent 3. So obviously this number over here should have at least 10 balls: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what happens over here, the physical representation of these balls or physical quantity, we are actually representing in something called symbols. So when we are saying it is 1, actually it is not 1, it is a symbol which is representation of this 1 ball. When I'm saying 2, so this is not 2, it's a symbol which is a representation of physical quantity, which are basically 2 quantities. Similarly 3, what is 3? This is a symbol which is a representation of 3 physical quantities, that is 3 balls, or let's say 3 chocolates. Now what happens in the representation of 10? So when we got this letter 0 derived from Aryabhata, so what we also use, we first use it for cancellation, which we just discussed, that is 4 minus 4 gives me 0, but we also use it to represent the increase of the numbers. So how did we do it? That as and when it comes to 9 and we have the 10th place, so for 10th place we use the number 1 and just put 1, 0 over here. So this 1 and the 0 actually represent these 10 balls. Now we may want to look at this chart, that we first had 1, then we had 1, 0, 10, then we had 100. So what happened when we got this 100 symbol? This essentially means is that our whole counting system, when we increase to the letter 100, so when we increase it to the letter 100, so this will keep going, like over here you'll get 11 and 12 and 13 and 14, and this will keep, and I will get over here essentially 110 plus another 10, which essentially represents 20, right? And then we'll get again increase of the numbers over here, which will be like 21, 22, 23. It will keep increasing over here, and ultimately what we are going to get is nothing but 10 plus 10 plus 10, which is nothing but 30. Now when we are talking that these numbers are keep on increasing, what happens if 10 adds itself, keeps on adding itself, how many times? Let's say 10 times. 10 times. So probably I want to make some space and explain it quite nicely So let's delete this over here. Let's rub and make a little bit of space and understand, what if I'm gonna get 10 rupees daily as a pocket money from my parents? Let's take that example. That what if I'm gonna get 10 rupees daily, I'm gonna get 10 rupees daily as a pocket money from my parents. Yeah. So one day, day number one, I get this. Day number two, I get this. And I'm not consuming, I'm keep on saving that, because saving is very important in life. So I get this and I get this. So when we keep on increasing and adding the same number, and we're adding this 10 times, 10 times. So when we multiply 10 times 10, essentially what this means is that we are adding 10 times. And this will represent the letter which we were talking over here, 100, which is 100. And what if I'm taking 100 10 times? So what I'll do is I'll write 100, 100, 100, 100. But is it a very time consuming process? Yes, I think it is. So instead of adding this 10 times, what I'll do is simply I'll write 100 and I'll write times 10, 100 times 10, which is 100 multiplied by 10. So this gives me 1 into 1, 1, and 3 zeros come over here. So I get 1000. So just by invention of this letter 0 by this guy Aryabhatta from India, got us Indians very high on a global stage. So though everyone has a contribution, we have contribution of Greeks, Latin, Middle East, as we discussed, 1 to 3, Romans, but yes, Aryabhatta has a contribution of 0, which first allows us to cancel and also allows us to increase. The only problem is we haven't been able to understand 0 yet. But yes, we'll try to. Now what we'll try to do over here, we'll try to go for new numbers. So I'll just try to delete this and see that what kind of numbers can we increase just by putting number zeros. So let's say I have this number, I have this lucky number, my lucky number is 9, yeah. So I'm using this 9 as a number. Now let's say I'm putting 2 zeros over here, yeah. So what does it make? It means 900, or simply 9 times 100, right? If you have 100 rupees, so you know, yes, so I'll get 9 notes of 100. Now what if I have 3 zeros? So I'll say it's basically 9 times 1000. It's 9000, and actually a S come over here, yeah, hundreds, thousands. What does S indicate is that we need to multiply over here. Had it been the opposite, had it been like 900, so what does this TH indicate is that instead of multiplying, we'll divide. So this would have been, just by addition of this letter TH, it would have been 9 divided by 100, and it would be 9, again 9 over 9 divided by 100. So over here, since there is S, there is no TH, so I like 9 multiplied by 1000. Cool. Now let's try to put more zeros, and I'll just make some space over here. So what if I had over here 9, and we had, let's say, 9 and 5 zeros, 1 2 3 4 5, and I have these 9 and 6 zeros, 1 2 3 4 5 6. And what if I have 9 and I have 1 2 3 4 5 6 and 7? So let's try to figure this. So I have these 3 zeros and 2 zeros, which are 5 zeros. So this makes nothing but 9 lakh in Indian system of counting. Now if we have 4 zeros and 2 zeros, we can call it either 90, 90, putting these commas over here. So we can either count it like 90 and lakhs like this, Or in international system of counting, we'll simply count the number of zeros. So I have 6 zeros, so I can write 9 into 1, 2, 3, 4, 5, 6, and this can be called 9 and million. And what if I have 7 zeros? So I can count it this way, 9, and I'll put some commas. I have 1, 2, 3, and then in Indian system, after 3, we count for 2 and count for 2 spaces. So in total, 2 plus 2, 4 plus 3, 7. So I have 7 zeros, so it becomes 9 crore. And had it been 9 times 9 zeros, 9 times like this, times 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 3, 3, 6, 3, 9. So this would be called 9 billion. And obviously, if it will be 3 more zeros, so that will be called, let's say, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I will have 3, 3, 3, 3, 3 times 4, 12. So this will be 9 trillion, which we heard, a trillion economy nowadays. Let's see what happens for it. So over here we have 9 trillion, we have 9 billion, and we have crore, and we have lakh over here, and we have million. So these zeros invented by the word Aryabhatta has been really beneficial, and this whole number system was contribution of all the civilizations together coming up for the betterment of human. Thank you.